Hello everybody, and tonight I'm going to be giving you a quick update on the current state of the Busk Hero. So tonight's video log is just going to be about the code, right? So I spent a couple hours this week just thinking about how I wanted this machine to work and putting together a primary implementation. And as this lives now, it's almost completely operational. There's just one or two things I have to iron out syntactically. And then one whole thing to add, but I'll go over that later. So I'll just walk you through step by step. Everything is labeled, so at the top here it's just the description of the project, and then below I go step by step through my buttons. So we've discussed these fret buttons in the past, and that's just simply giving a definition to the neck of the Busk Hero. And of course, as we've seen many times before, we will also be doing this kind of smart button control where we have the states of each button. So we have a nice button press where if it's on, and if it's off, and it won't get too excited there. We also have notes. So these are what the buttons control. That's why I put it with the button variable section. And it's just an array of 5 notes, 1 note per button. And these are going to be MIDI values later. And I'm going to come back to this, so we will not forget about this for a while. Okay, so then moving on to the plus and minus buttons. I know I mused last week about using it as like a reverb control, but I was thinking about actually using this as a musical instrument, and I was thinking, okay, how am I going to have 5 notes and actually play a song, right? So I figured, okay, what if I did this? What if I had it control like a major third? So in its normal position, let's say we had middle C and then C sharp, D, D sharp, E, and that's 5 notes, right? So I figured what I'm going to use it for is I'm going to control the MIDI note values that the buttons control with the plus and minus buttons. So I'll go ahead and actually start there. The way I've rigged this up is that, so it's the same kind of button scenario where we have these button states as the frets, but down here I've got a variable called shift val. And now what shift val does is when we are calling a MIDI note, as you can see here, the note that we call is equivalent to this note, which is obviously one of these notes up in this array right here. That note is going to be one of these notes plus shift val. And now depending on where we are, I'll go ahead and show you. Shift val is either going to be positive or negative, right? And I've got it so it's incrementing in groups of 5. So as you can see right here, if the minus state is being pressed and all the conditions are met, shift val is shift val minus 5 now. And so let's say shift val is shift val minus 5. When we get to this function down here, and we're deciding what note is going to be sent as a MIDI on message, it'll look through here, and let's say the corresponding button was pressed for MIDI note 54, right? The computer would read 54 and then ask, okay, what's the shift val? And since we just said the shift val was -5 because we just pressed the minus button, the MIDI note that's actually going to play is 49, right? And corresponding to whatever that may be, that note will be played when all the conditions are met. But I really quickly want to let you know what happens chronologically and how those notes that are being controlled by the shift val, how those notes are even triggered. So let's just go into the loop where everything happens, okay? So obviously up here I'm not going to spend any time talking about the setup with the pin modes. We've seen that before, and that would be a waste of your time. So inside the loop, I just have some comments here that kind of guide you along. We're checking the components, right? So first we have check buttons, right? And check buttons is kind of our main sketch where we go in and we check if any single button is on. So that's the fret buttons, and that's the plus and the minus buttons. So really quickly, let's just jump into check buttons. Now, if we have an array that we're cycling through, right, of fret states, which we know we do have up here. Here we are. We can use a for loop to control the setup for these fret buttons. So as you can see, this little block of code right here, this for loop, is all it's doing is reading the states of the frets, whether that may be high or low. We can use that to control something later. And this is the same type of thing that we've seen in the past. You should be really, really familiar with the keyboard button by now. So yeah, it's the exact same thing. And inside this, right, we have another for loop where we decide, is this button pressed, right? So say I was pressing the second button, right? It would cycle through this for loop, and when it got to the 1 position within the current fret states array, it would say, oh, that one's on, right? If I was pressing it, it would say the current state is high, right, as we've just decided up here, and the last fret state is low, right? So then we can go ahead and go into our if statement. So this is just some commented out serial print things that we don't really need to worry about. It's self-explanatory. If all of these are true and we are pressing this button, right, on the guitar neck, I want to run a MIDI on function, right? Does that make sense? Great. So if it's off, if it's not on, of course, like if we release the button, it'll run this else if statement, which sends a MIDI off message, and I'll go over that in a second. But let's just jump into the MIDI on really quick. Okay, great. So the way I've kind of dreamt up this project, and I mentioned this last week, was that I want to use the flex sensor as kind of the master trigger for when something is happening, right? So even if I'm pressing a button on the guitar neck, nothing's going to happen unless this flex sensor is actively being pressed, right? It's almost like a guitar, right? You can touch the strings on the neck all you want, but until you strum or pluck that string, nothing's going to happen. So what I have it doing here is this is pretty much just, this is analog reading the pin that has the flex sensor in it. And what it does is I think I mentioned it's reading in values of about 80 consistently, the way I have it bent on the guitar face. And what I want to do is I want to somehow detect when that is, that's different than 80, right? So when I press down on that, we're going to be getting values of about like 75 to 80, right? But pretty much it's going to stay above 80 when it's not being pressed on. And we're going to take that for granted, right? So I'm analog reading the flex sensor, and then I want to run the flex control function, right? And so I've encapsulated this such that the flex control function will run here, and I decide if flex val is less than 80, and we decided earlier that that means I'm pushing on that flex sensor, and because when we push on it, that flex val is going to get lower. It's going to be read in very, very quickly. As we're reading that in, if it's less than 80, flex state equals true, right? Otherwise, it's going to be false, right? So in its normal position, flex state is always false. In the normal pressed state, right? If I'm just pressing down on that flex sensor, flex state is going to be true, right? And now what happens if flex state is true, as you can see right here, is we're going to send that MIDI message that we talked about earlier, right? So to briefly go over that one more time, what needs to happen for a note to be sent? First of all, you need to be pressing one of the buttons on the neck, okay? And while you're pressing one of the buttons on the neck, the flex val has to be less than 80, which means you have to be pressing on that flex sensor. So much like a real guitar, I'm holding button 1, and I press on that flex sensor. That should be this, the conditions that satisfy the note being sent to the computer as MIDI, right? And then once again, you can see that we are going to take into account the shift val. And the same exact thing happens in the MIDI off function, which we showed up above, except this time we're going to be sending a MIDI off message just automatically if that button is not pressed anymore, right? Because I don't really want to have it so much like a normal guitar where if you just strum, if you press that flex sensor, there will be a sound no matter what. That might be cool in the future, but for now I want to have it so if you're not pressing a button, the conditions aren't met for sound. I think that's just a lot easier to understand. Last but not least, there's going to be a soft pot control, right? Now, if we look up in the loop up here, that's my second function that I call here. I've got my soft pot control, right? And so I'm reading in a soft val from that soft pot, and that's going to be a resistance. And I discussed this in the last video. We've gotten it down to some values that we can kind of recognize. And I haven't written the code for this, but the basic idea of what I want to do is I want to check if that soft val is above 200, right? And I remember, if you remember, I mentioned the soft val is normally always just below 200. It kind of oscillates from between 0 and 200. That's just when you're not even touching it. I'm not totally sure mechanically why that is, but it must be receiving some kind of like force, maybe from like the air or just from being on a surface. I don't really know about that, and I don't care that much. All I know is that the values that we're going to be using when we're touching it, we want to check if those are above 200. So if those are above 200, soft control equals soft val, right? So soft control val, what that is going to be some kind of control parameter, right? So I want soft control val to be that analog resistance that's coming out of soft pot control, and then I want the computer to be sending a MIDI control message based on soft control val. Now, if you don't know, MIDI control message is something that your digital audio workstation can read in to affect a parameter of maybe an effect or something else. It's pretty much a digital model of a control voltage in like an analog synthesizer, right? So this value, soft control val, is going to be used right below, as I've commented in, to send a MIDI control message based on soft control val. Got it? And if that soft pot val is less than 200, which is the else, soft control val equals soft control val, that's not really doing anything. But visually, I wanted to put that in so that I myself would remember that when the soft pot val is not being affected, the computer is going to remember what soft control val is, and thus that message that you just sent to your DAW is going to stay completely the same, right? So say it was controlling cutoff. If I somehow got the cutoff down to like 1.5K of a low pass filter, so we're cutting off all those highs, I want, after I release that soft pot, I want that cutoff to stay at 1K until I put my finger on there and change it again, right? I wouldn't want it to just snap right up again. I think that's kind of not user-friendly. I'm not totally sure if this is the correct spot to send the MIDI control message. I'm not totally sure how the control messages work when they're talking to the computer. If the computer reads in that control message and then keeps that there until it reads in another control message, then this spot right here is perfect. Otherwise, if it maybe if it like times out at a certain point, or as soon as it's not reading in a control message, it snaps back up to its original value. That would be no good, and I wouldn't want that to be the case. I doubt it. I'm assuming it's what I'm assuming it just stays at that value you originally gave it. So I'm not going to really worry about that until I give this a test inside the computer. Other than all this, the last thing left to do for me would be to implement some kind of effect or pitch bend based on that joystick. I mentioned earlier that joystick is just two potentiometers that give me analog x-axis and y-axis values. That's probably going to be no problem. I just got to think about a creative way to use that. And once I get this up, I'm going to hopefully do some laser etching on the front of the guitar to do some nice art. And I really just got to learn how to play this thing. It's going to be tough because I only have like a major third to work with at a time, but I bet if I'm burning on those plus and minus values, I should be able to learn how to play really fast. So all my parts are also bought already, so I don't think I need to be buying anything else. And I think that's it. As I mentioned before, I'm going to implement the code like this. And once I'm sure that it's working, I'll open up another file for like the Busk Hero 2.0 code version, and I'm going to put everything into classes and and make it into objects and just really encapsulate this code nicely. Get some polymorphism going. That's some good stuff. Yeah, but before I do that, I want to make sure that just everything's working. And yeah, this really isn't a complicated project at this point, but I think that it's a good little bit of review of everything we learned, and it's going to be a really good learning experience to put everything into class format. So I'm really looking forward to that. But as always, stay tuned till next week, and I'll have another update video for you. Actually, next week we'll probably have a full update lab, so expect some nice photos and maybe another video, and we'll discuss again a little bit about the hardware, given we just talked about software this week. So with that, I hope you enjoyed this video if you stuck around the whole time, and have a good night. Bye-bye.